Welcome to 1.1 function notation. Let's just review how we evaluate functions using function notation. So in the first couple of examples, we have a number inside parentheses after the name of a function. So the name of the first function is f. If we find f of 0, that means that we're going to take all of the x's and turn them into zeros. So we're going to have 2 times 0 cubed plus 5 times 0 minus 3. Let's make that a 3. So that gives us 0 plus 0 minus 3. So f of 0 is 3. Oh, negative 3. This is a point on this function. So this means that one of the points on the function could be graphed as 0 comma negative 3. So we could say point at 0 comma negative 3. For the next example, we're finding g of 1. And I put this one on there on purpose because it's nice trig that everybody loves. So trig can be a little sneaky because I'm going to take that x value and I'm going to plug it in. And then I have to think to myself, is this something that I can evaluate without a calculator? So cosine of 1, well, 1 is the angle. Angles that you know are like pi over 6, pi over 3, pi over 4, pi over 2. We don't have cosine of 1 on our unit circle. And so what I'm going to do is I can either plug this into the calculator or I can leave it as g of 1 equals cosine of 1, which means that the point on the graph is 1 comma cosine of 1. In the next example, we have multiple functions being evaluated. So in the next function, we want to find g of 2 minus h of negative 3. So that means I'm going to take g, which is cosine of x, and I'm going to plug in 2. Then I'm going to subtract h of negative 3. So I'm going to take h, which is square root of x plus 5, and I'm going to plug negative 3 into that. Cosine of 2 I'm going to leave alone because it's not on my unit circle, and I'm looking for exact values. In the square root, we've got 5 minus 3, and so that's going to be square root of 2. That's irrational, so I'm going to leave that alone. In the next one, very similar. So we're going to say f of 5 plus g of 0. So f of 5 means I'm doing 2 times 5 cubed plus 5 times 5 minus 3. So that's f of 5. Then I'm going to say plus g of 0. So I'm going to say cosine of 0. Well, let's see what we can do here. 5 cubed is 125, I think. 125 times 2 is 250 minus 25, or plus 25, sorry, minus 3, plus, now cosine of 0 we can do because 0 is an angle on our unit circle. So cosine are the x values. The x value when the angle is 0 is 1. Then we're going to be able to say, let's see, 250 plus 25 is 275, minus 3 is 272, plus 1 is 273, hopefully. My calculus, pretty good. My arithmetic, sometimes not so good. All right, next one. It says f of g of 2. So we've got a composite function here. So what I'm going to do with this one is I'm going to start with the middle. I'm going to leave the f alone, and I'm going to figure out what g of 2 is. So g of 2 is cosine of 2. Cosine of 2 can't be evaluated, so the best that I can do now is take cosine of 2 and plug it in for f, okay? I could, if I wanted to, plug cosine of 2 into a calculator and come up with a decimal value, but I'm more interested in keeping these values exact rather than rounding off a decimal. So that means f is going to be 2 times x, which in this case is cosine of 2, cubed, plus 5 times cosine of 2 minus 3. And that's as far as we'll take that one. Next one is f of h of 4. So I'm going to start with h of 4. I'm going to leave the f in front. H of 4 means I'm going to do square root of 4 plus 5. So 4 plus 5 is 9. Square root of 9 is 3. So that turns this into f of 3. And f of 3, I'm going to do 2 times 3 cubed plus 5 times 3 minus 3. Let's see if we can piece this out. So 3 cubed is 27 times 2 is 54 plus 15 minus 3. So 54 plus 15 is 69 minus 3 is 66. Next, we're going to do g of f of negative 1. So I'll leave the g outside. I'm going to have to scroll up and down a bit here. So we're going to say g of, we're going to do f, which is 2 times negative 1 cubed plus 5 times negative 1 minus 3. So that's going to give me g of, let's see, this is going to be negative 2 minus 5 is negative 7, negative 10. And then g is cosine, so we're going to make this cosine of negative 10. That's definitely not on our unit circle, so we're leaving it alone. If you wanted to, like I said before, you could come up with a decimal approximation. G of x. I didn't put a number in this one, and that may have been an accident, but we're going to give this one a shot again. So g of x, I'm going to start with the g of x here. So we're going to do g of cosine of x. And then g of cosine of x means we're doing cosine of x, and that x is cosine of x. Let's try f of g of h of 2. So now we're just continuing with this composition of functions. So we're going to start from the middle. We're going to start with h of 2. So I'm going to leave the f and the g alone. H of 2 is going to be square root of 2 plus 5. 2 plus 5 is 7, so this just became f of g of square root of 7. Now I'm going to work on g of square root of 7. So I'm leaving the f alone. And I'm going to do cosine of square root of 7. And then f is 2 times your x value, which is cosine of square root of 7 in this case, cubed, plus 5 cosine square root of 7 minus 3. And the last one has a little bit of everything. So we've got a little composition, we've got a little division. Let's give it a shot. So on the outside here, I'm going to work on the g of 0. So I'm going to say f of g of 0 is cosine of 0. Over here, h of negative 1, well, that's going to be square root of negative 1 plus 5 over g of 0, which is cosine of 0. So we've got that in a couple of places. Cosine of 0, we said before, was 1. So I've got f of 1 minus 5 minus 1 is 4. So this is square root of 4 up top and a 1 on the bottom. F of 1 is 2 times 1 cubed plus 5 times 1 minus 3. Then this is going to be minus square root of 4 over 1. Well, square root of 4 over 1 is square root of 4, and square root of 4 is 2. So here we have 2 plus 5 minus 3 minus 2. So what do we have? 7, 6, 5, 4, 3, 2 is my answer. All that work to just get 2. Next page, finding inverses. The trick to finding inverses is to remember that inverse just means switch your x and your y. So for this first example, I'm going to turn the x into a y and vice versa. So this is going to become x equals 2y minus 4. And to make it look like a function that we're used to seeing, we're going to solve this for y. So whenever you can, in these cases, solve it for y. So I'm going to do plus 4 and get x plus 4 equals 2y. I'll divide by 2 and get y equals x plus 4 over 2. Or if you want, 1/2 x plus 2, so that it looks like y equals mx plus b. Next example, the y becomes an x, the x becomes a y, and I go ahead and solve. So I say minus 3. So x minus 3 equals negative y. Divide by negative 1 and end up with y equals negative x plus 3. Let's try the same process with quadratic functions. So I'm going to make this x equals y squared minus 5. Add the 5. So x plus 5 equals y squared. And then when I have something squared, I'm going to take the square root. Don't forget plus or minus. I'm going to write you a note there. So that says don't forget. So that gives us y equals plus or minus square root of x plus 5. And this is really important because y equals x squared minus 5 is a function. It passes the vertical line test. If I have both the plus and the minus of square root of x plus 5, I end up with that parabola. Here's positive square root of x plus 5. Here's negative square root of x plus 5. So that's the parabola being reflected about the line y equals x, but it's not a function. Next example. So we'll do the same thing. X equals 1/2 y squared minus 2. I'm going to add the 2. So x plus 2 equals 1/2 y squared. Multiply both sides by 2. So 2x plus 4 equals y squared. Take the square root of both sides. Don't forget that plus or minus. And end up with y equals plus or minus square root of 2x plus 4. Okay. Let's try it with a couple of root functions. So I'm going to say x equals square root of y plus 4. To get rid of the square root, I'm going to square both sides. So I'm going to have x squared equals y plus 4. Then I'll subtract the 4, and I get y equals x squared minus 4. Last example on inverses, I'm going to say x equals 2 square root of y minus 3. I'll add the 3 first because it's not under the square root. So we'll say x plus 3 equals 2 square root of y. I'll divide by 2. So x plus 3 over 2 equals square root of y. I'll square both sides and end up with y equals x plus 3 over 2 squared. Or if you wanted to, you could write it as x plus 3 squared over 4. Or if you wanted to, 1/4 x plus 3 squared. It's up to you. For the last two examples, we're still doing inverses, but we're not finding the inverse of a function. We're graphing the inverse of a function that's given to us. So what I would recommend you do, and I've highlighted some points for you, is pick a few points on the graph, especially where the graph does something important, turns around, has a little squiggle in it, whatever it might be, and make a list. So the first point is -4, 4. The second point is -2, 1. Then we have 0, looks like 3. We have 2, comma 0. And we have 4, comma 2. Then go ahead and take each of these points and flip-flop the x and the y. Just switch them. So this becomes 4, comma -4. I'm going to plot that one. So I'm going to go over to 4. I'm going to go down 1, 2, 3, 4 points and plot that guy. Then this one becomes 1, comma -2. So I'm going to go over 1 and down 2. And as I go, I know that those 2 points were adjacent to each other. So I'm going to go ahead and connect the dots. I'm going to make the next point 3, comma 0. So I'm going to go over 3 and up 0. And then again, connect the dots. Then 2, 0 becomes 0, 2. And that's right here. And I will connect the dots. And then 2, 4. So over 2, up 1, 2, 3, 4, and connect the dots. And what you should be able to see is that if you fold this page, I'm going to draw in the line of symmetry along the line y equals x, that you have mirror images on either side. So you can see the point out here maps to the point over here. It's symmetrical, the same distance from the line y equals x. Let's try the same thing with the next one, not straight lines this time. So I'm going to take some of those points. So I'm going to take the point -5, comma 4. The next point I'm going to take actually doesn't have a dot on it, but it seems pretty significant. I've got a little bit of a quadratic feel going on here. And so I'm also going to map the point at -3, 0. So there's -3, 0. Then we've got -2, comma 1. We've got 0, comma -2. And then we've kind of got this weird squiggle going on. I think we can handle it. So let's deal with 3, comma 2. So then I'm going to go ahead and I'm going to map each of these points. So 4, comma -5. So I'll go over 4. I'll go down 5. Whoops, I didn't leave myself enough room. I'll put it right there. Then -3, 0 becomes 0, -3. So there's 0, -3. And that's where the squiggle is. So I'm going to kind of give it a squiggle. Doesn't have to be perfect. Actually, it should go the other way now that I'm looking at it. So we want to make sure it goes this way as my hand shakes a little bit. Then we're going to have 1, comma -2. So 1, -2. Something feels wrong. 0, -3. We'll go with it, see what happens. If you could see it, email me and let me know. And then we've got 0, -2, so that's going to be -2, comma 0. And then 3 comma 2 becomes 2 comma 3. And there's definitely something wrong with this one, and that happens sometimes. If you can figure out what's gone wrong, if you're watching this video and figure out what's gone wrong, email me and I will fix this in the notes. It looks close to right, but definitely not it. Definitely not it.